Exercise 1721 is asking you to draw the products for an electrocyclic reaction. So you're going to have a conjugated pi system, and the electrons in the pi bonds are going to move over. All of them are going to move over to create a new ring. So it's electro for those electrons that are moving, and cyclic because they're all going to move over. So you can take that area and pick a direction either clockwise or counterclockwise and move each of those pi bonds over in that direction. So here I chose to move clockwise. And just so we can better follow the movement of the electrons, I'm going to draw them in these colors. So that will be green, this one will be blue, and then the top one will be purple. So I'm also going to number these. So say this will be, and just in this 6-membered system, the conjugated pi system, that's what I want to number because that's where things are going to be changing. So first let's just draw the ring, and then we'll worry about these branches that are going to come off of the ring that's forming. So we have that 6-membered ring at the left that stays where it is between so here I'll fill in these numbers. So the green bond between carbons 5 and 6, that moves over to go between 4 and 5. The blue one between 3 and 4 moves over to go between 2 and 3. And the purple bond, the pi bond here between 1 and 2, that goes to form this new sigma bond. So that's the ring. Now let's think about the branches. Off of that ring, coming off of carbon number 1 and carbon 6, we have 2 ethyl branches. We need to know the direction that those are going to go in. Now we've used heat here, so we know we're at the top of this table. And also we had 3 conjugated pi bonds in this system, so we know we are at the right of the table. And if we look at these branches, the top one is going up and the bottom one is going down. So we have up, down. And so those 2 ethyl groups that are coming off will need to be cis. In order for the molecular orbitals to overlap to form that new sigma bond, those ethyl groups are going to have to be cis. So it doesn't matter whether you have them both coming out at you, like I'm drawing here, or if you had them both going away with dashed wedges, but whichever way one is going, the other would have to be going too. And so this is the product for that reaction. Let me just erase all of the little notes so that you can appreciate how much these sigmatropic rearrangements, how much these electrocyclic reactions can change what a molecule looks like. Okay, now all of the electrocyclic reactions exist in equilibrium, so they're forming rings and the rings are coming undone. And so this one is giving you the ring already formed and asking you, what does this look like when it comes undone? So here I'm going to number the carbons in the ring, just so we can think about it a little more precisely. And in this one, you only have 1 pi bond in the ring. Notice notice that when you have 3 conjugated pi bonds, when you form that ring, you end up with 2. Well, here we only have 1, and that's a sign that we didn't have 3 conjugated pi bonds. We only had 2 conjugated pi bonds to begin with. So here, we're going to pick a direction again. I'm going to go clockwise, And we'll take that pi bond and move that clockwise, and the sigma bond that's opposite it will move clockwise too. So I'll redraw what we have so far. Oh, oops. Okay, and just so we can follow along a little better, here I'll make this bond in green, and those other electrons that we're moving I'll put in blue. So the green electrons move the green electrons, the ones between carbon 2 and 3, those move and become a double bond between carbons 2 and 1. That's what's happening here. The blue electrons in the sigma bond, those are going to form a pi bond between carbon 2 and 3. And when they move that way, they move away from the sigma bond, so those move. So now we have this molecule, and we just have to worry about, so we've undone the ring, we just have to think about these carbon branches coming off of carbon number 1 and carbon number 4. Should they both be going up? Should one be going up and one be going down? What we have here is heat. We're using heat to make this happen, and so we know we're going to be in the top 2 rows of this table. And we also know that we have two pi bonds in our conjugated system, so 2 conjugated pi bonds. And we saw that in the ring, the 2 branches are cis, and that only happens if they were both going up or down, if they were both going up or both going down in the original molecule. So here I'm going to put them going up. The top one, that's an ethyl group going up, and the bottom one would also need to be an ethyl group going up. I could have drawn both of those going down too. Now this looks a little strange because I have 90-degree angles for my bonds, so if I wanted to draw that in maybe a more conventional way, I'll draw it like this. I'll number it like this, and then I can fill everything in. So I have methyl groups coming off of carbon 2 and 3, pi bonds between 1 and 2 and 3 and 4, and then off of both of these I have ethyl groups going up. So those are really the same. These two are the same molecule. If you were taking a multiple choice test, or a test where they give you possible answers, like in an MCAT sometimes, or maybe a DAT, or another standardized test, they would probably draw the molecule like that. But when you're first trying to figure out what it is, it's nice to have an analogy between the molecule you're drawing and the original molecule to sort of help you work your way through and see the connections. Okay, in this next one, we have 3 conjugated pi bonds. So let me number the carbons around those. And I will fill these pi bonds in, those electrons in with different colors so we can see how they move. So once you have that, just pick a direction. I'm going to go clockwise here and move all of those pi bonds in that direction. So this green one I'm going to move to create a sigma bond between carbon 1 and 6. The purple will move to create a pi bond between 4 and 5, and the blue will move to create a pi bond between 2 and 3. So I'm going to draw first something that looks a little weird, but it'll resemble that original structure. And then once I have that, I can always change the way it looks. So let me number this. So those green electrons at the top, between carbon 1 and 2, those are going to move to create a sigma bond between 1 and 6. The purple electrons between 5 and 6, those move to create a pi bond between 4 and 5. The blue electrons between 3 and 4, those move to create a pi bond between 2 and 3. We still have those methyl groups coming off of 3 and 4. And now we have to think about these two ethyl groups coming off of carbon 1 and carbon 6. Will they be cis or trans in our ring? So we see we're using heat, so we know that we're in the top two rows of this table. We have 3 conjugated pi bonds, so we know we are at the right here. 3 conjugated pi bonds. And the branches are both going up, so this, if you look at this top one, you can see that branch is going up, and the bottom one, the ethyl branch, is going up off of the ends of that conjugated system. So if they're both going up, that means they should be trans in your product. So we'll have one ethyl group coming out of us, and the other ethyl group going away from us. Now that is a nice first step because we can see the connection between it and the original molecule, but it's good to draw these with more standard bond angles. And so in a 6-membered ring, you would normally draw a 6-membered ring like a hexagon. We can number these. And then we see that we have methyl groups coming off of carbon 3 and 4. We have a pi bond between 2 and 3, and between 4 and 5. And then we have 2 ethyl branches, trans, so one going towards us and one going away. And so that would be your answer for what happens when you heat this molecule up.